Of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 17, Center of Excellence, section number 1 on SIL, Safety Integrity Level. SIL, Safety Integrity Level, section number 1. Okay. Center of Excellence, lecture number 17, SIL Study Guidelines, section number 1, Safety Integrity Level. Okay, purpose of Center of Excellence. First, over here, where we are now, where we want to be, what to do, and how to do. That are the 4 pillars in order to achieve Center of Excellence. Okay, we have already discussed the first here, the hazard operability management system, and here hazard, and now today we're going to discuss a SIL, Safety Integrity Level Management System. Okay, Center of Excellence, warning pathway, delivering on commitment, differentiated performance, enabling profit optimization process. Okay, we can see the first here, the safety of personal safety, co-workers, contractor, and community safety, and it must be reliable. Second, environment compliance of process and asset safety, work safely or not at all. Production rate at plan or product on specification, there is always time to do it right. Continuous improvement, if it is worth doing, it is do it a better ways. Okay, this is my working parameter. So in order to achieve these goals, so we need to have the different discipline engineers: petroleum, chemical, electrical, instrument, mechanical, industry, and civil. Okay. The specialty: loss prevention, safety engineer, process engineer, operation engineer, optimization, all discipline maintenance engineers, corrosion engineers, integrity, reliability, cost, budgeting engineer, and project engineer. Okay. In order to achieve the personal safety, co-worker, contractor, and community services, as we have discussed over here. Okay. In order to achieve what we have to do, Center of Excellence for the engineering best practices. Okay. SIL, the Center of Excellence objective. First, we're going to discuss, then scope here, then application and policy. How to implement it, SIL, Safety Integrity Level. Okay. This is my forward message. This document has been developed by corporate HSE support department, reviewed and edited by the corporate quality management system department, and circulated for review by user department before being endorsed by oil and gas company management for use as per the company guidelines of policy for safety integrity level to determine and to address issues. This document published for the oil and gas companies, operation department, contractor, and consulting utilizations is also present from reflects as far as possible current corporate requirements, taking into account the non-available industry best practice and the applicable latest national and international codes and standards. This document is subjected to periodic review to reaffirm its adequacy or to conform to any changes in the corporate requirements or to include a new development in its subject matter. This is recognized that this will be case where the agenda, data sheets, or other clarifications need to be attached to HSE publication to suit a specific application or service involvement. As such, the content of the document should not be changed or re-added by any core company or the contractor, suppliers, agent, etc. Any data or clarification entailing a major change shall be brought to the attention of custodian department. All comments, views, recommendations about the documents forward to me, g.masood.dr@path.edu. Okay, SIL studies. Today we are going to discuss first abbreviations, then references and codes, team structures, planning, SIL study with calibrated risk graph method, SIL study LOPA method, reporting and follow-up, SIL verification report, SIL requirement specifications, SIL validations, and appendix. These 13 points we are going to discuss next couple of days. Okay, SIL introduction. Safety integrity level SIL studies an analysis which aims of determination of the appropriate reliability level and required from the elements of the safety instrumented functions SIF identified in prior safety study, that is HAZAP. The approach of this guideline is to remove the uncertainty regarding the safety integrity, cost effectiveness, and availability requirements, reducing over and under engineering in traceable manners. SIL study is a method to record the SEF for a project development and document the expected reliability level. SIL study provides a basis for the future maintenance and operating strategies. SIL study shall be conducted during a feed phase and EPIC phase in accordance with engineering health and safety plan or as required by the outcome of the safety studies of a project. SIL assignment is based on the amount of risk reduction that is necessary to mitigate the risk associated with the process or to a tolerable level. All of the safety instrument system SIS design, operation and maintenance choices must then be verified against the SIL assigned. Okay, so next is the scope. To specify the structure, responsibilities and technique of the safety integrity level. Okay. It demonstrates as the guidelines details the structure, responsibility and techniques of the safety integrity level study using a calibrated risk graph and a LOPA methodology. Calibrated risk graph methodology shall be primarily followed for a SIL study. However, the SIL levels assigned with a 3 and above or using risk graph methods shall be further verified by LOPA methods. LOPA method can also be used when the SIL assessment team are using risk graph method to unable to reach the consensus agreement on the target SIL level. The guidelines also detail the requirement for the safety requirement specification, SIL verification and SIL validation for a project. Okay, application. The SIL study of the project shall cover all safety instrumented function SIS in the process, vendor packages system, utility system and foreign gas systems associated with ESD systems where there is a potential for hazard to human safety, environment or assets of production loss. Okay, next is the policy. Okay, SIL policy. All oil and gas companies are committed to protect the health and safety of its employees and others that may be affected by its activity and to give proper regard to the conservation of the environment. The company policy is to conduct its activity such that it strives toward an incident-free, secure, safe and healthy workplace. Safety studies and reviews shall be performed during the course of a project or a modification to an existing facility. This is to identify, qualify, quantify and to establish that design safety measures shall provide adequate protections and mitigate any risk involved with the proposed project development or the modification. SIL terminology here. The first is BPCS, a basic process control system, a combination of sensor, logic, solvers and final elements which automatically regulate the process within a normal production limits. The BPSC provides a control of process on the desired manner. Okay. The next is the cause, and then company, oil and gas any company, and then the loop system. First, the cause. The factor contributing alone or in combination with others to release of hazards. In this guidance, the sums to the demand scenario triggering a SIF. Okay. Then the loop, that is layer of protection analysis. Layer of protection analysis. A process of evaluating the effectiveness of independent protection layers in reducing the likelihood or severity of undesirable events to meet organizational need. Okay. The next is a consequence of failure on demand. Escalation events that happens after the failure of the SEF during the solicitations affect on personal safety, economic loss, environment effect. Okay. Then the consequences. Okay, the consequences are the result of the failure of control for the absence of control to prevent an incident that are usually expressed in terms of injury, loss or damage to people, assets, production, environment, and reputations. That is, next is the contractor here. A firm which has entered into a legal binding business agreement, contract to supply a product or provides services in a company. The terms is also sometimes applied to suppliers who are available to provide services but are not currently in a contractual relationship. Okay, so next is the demand rate. The number of times per year that the hazards event would occur in the absence of the safety instrumental functions under consideration. Okay, then the demand scenario. Demand scenario, the set of conditions trigger a SAF actions. Then is the design intent of final element. Design intent and then the final element. Design intent, the reason why SEF is set, it has purpose, and final element, a device which manipulates a process variable to control ESD, BDV valves, and motor driven, etc. Then the hazards and incident. A source of potential harm or damage, or a situation with potential for harm or damage. The last here, incident here, are general terms for an unplanned event or a chain of events which has or could have caused injury, illness, damage, or loss. It is used to include accident and near misses. Okay. Next, okay, layer of protection analysis. First over here. A process of evaluating the effectiveness of independent protection layers in reducing the likelihood or severely of an undesired events to meet organization needs. Next is the licensor. A licensor or a process licensor means each of the companies which have granted or will grant to a company a process license or have provided or will provide the cross-pending license basics engineering package BEP during the feed project. Okay, next is the logic solver. The elements of BPCS or SES that implements one or more logic function. Occupancy here. F. The probability that the exposed area is occupied at a time of the hazards events determined by calculation the fractions of the time the area is occupied at the time of the hazards event. Okay, next is probability avoiding the hazards. The probability that exposed a person is able to avoid the hazard situation which exists if the SEF fails on demand. Next is the probability of the failure on demand. The probability that a system fails to perform a specified function are on demand. Next is the recovery measures. All technical operational organization that limit the chain of consequences arising from a top event and assist return to normal operation. Okay. Safety integrity level. SIL. SIL is defined as a relative level of risk reduction provided by a safety functions or to specify target level of risk reduction. In simple terms, SIL is a measurement of performance required for a safety instrumented function. 4 levels of SILs are defined. SIL 4 has the highest level of safety integrity and SIL 1 has the lowest. Okay. Next is the safety instrumented function. SEF is a safety functions with specified safety integrity levels. Instrumented functions can be either a safety instrumented protection functions or a safety instrumented control function. Next is the safety instrumented system. The instrumented system used to implement one or more safety instrumented functions. A safety instrumented system is composed of any combination of a sensors, logic solver, and the elements. The SIS performs specified safety instrumented functions to achieve or maintain a safe state of process when unacceptable or dangerous process conditions are detected. Safety instrumented systems are separate and independent. Okay, SIL abbreviation. First is CUFD, consequence of failure and demand here. Second is EPIC, engineering, procurement, installation and commissioning. ESD, emergency shutdown system. FEED, front end engineering design. F&G, fire and gas systems. IPL, that is the independent protection layers. HAZOP, operability studies, that is the hazards and operability study. And LUPA, layer of protections analysis. And LP, loss preventions. ORIDA, that is offshore reliability data. P&Is, that is piping instrument diagrams. Piping instrument diagram. PFD, process flow diagram. And PSD, process shutdown here. PSSR, the pre-startup safety review. Then the RRF, that is the risk reduction factor. SIL, safety integrity level. SEF, that the safety instrumented function. SES, safety instrumented systems. SRS, that safety requirement specifications. So SIL-related document, we can further review this document. Corporate philosophy for the fire and safety, philosophy of the HSC risk management, philosophy of the health safety activity project, interdepartment procedure and general management of the SIL, and capital project, etc. Okay, today we have discussed objective, scope, applications, SIL terminology, and SIL application. Okay, next topic, we are going to discuss team structure and responsibilities and reference standard and codes. Okay, there are a few references here. Okay, together everyone achieve more. Please do not hesitate to send me your feedback, comments, t.masood.dr@bath.edu. You may send me your message through WhatsApp. I have also provided my WhatsApp number. Thank you very much. Stay at home, stay safe, inspired, and blessed. Thank you very much.